Hello, what's going on? Question 8, last question, man. 1:30 is the time. I really need some Pepsi, man. Pepsi, I need some Pepsi. What? 1:30, 1:38, almost 2 o'clock. All right, let's try to do this question and get this done with, okay? Sorry about my lack of enthusiasm. What enthusiasm? All right, let's go to this question. First question. You've been given bunch of molecules here. Identify all the molecules contain carbon to carbon double bonds. Carbon to carbon double bond. Now, yeah, benzene ring has got carbon to carbon double bonds, but we don't consider them as exactly as carbon to carbon double bonds, right? So that's why we have to exclude benzene here. Uh, yeah, look, we don't normally say that's a carbon to carbon double bonds here. I mean, I can understand that some of you be thinking, sir, hasn't the benzene got carbon to carbon double bond? They're not really considered as just carbon carbon double bonds. So let's try to see whether we can find any other molecules which has got carbon to carbon double bond. Now look at that. There are some candidates here. This is a carboxylic acid here. It's like a fatty acid, isn't it? Now, do you remember the molecular formula of a saturated fatty acid or carboxylic acid? It has to be C14, H28, and O2. If there was C14, H28, O2. So this is a saturated one. So D is not an answer. What about this one? This one is tricky. This is ester though. You see that? Oh, this is a ester. So in order to do that, let's hydrolyze this ester because we need to get the fatty acid and the alcohol. So when you get the fatty acid, it has to be C17, H31 goes here, then CO and OH, right? That's the fatty acid part. The alcohol, because you have to put the H goes here, OH goes here, right? So the alcohol is methanol. That's simple. Now in this case, what's that? C18, H32 and O2. It has to be, for that to be saturated, it has to be 36, isn't it? 36. So we got only 32. So 4 hydrogen missing. 4 hydrogen missing means that fatty acid has to have a ah 2 carbon carbon double bonds, right? 2 carbon carbon double bond, because this has to be, if that was to be saturated, you had to have C18, H36 and O2. So 6, what? 36. Wrong. Wrong. 36 equal to 36, 32, 4, 4, 4, 4. Yeah, 4. No, that's correct. 4 hydrogen missing, 2 carbon carbon double bond. So definitely F is our candidate. Have a look at the D. D, it seems like easy. C18. Sorry about that. H30 and O2. So if this was to be saturated, you need to have 36. C18, H36, O2. Now this 6 hydrogen missing. 6 hydrogen missing means 3 carbon to carbon double bonds. So this has got 3 carbon to carbon double bonds, right? So this has to be F and G. F and G. Identify all molecules containing hydroxyl group. And there are so many molecules containing hydroxyl group. A has got hydroxyl group, B has got hydroxyl group, C has got hydroxyl group, D, no, this is not hydroxyl group, this is a carboxyl group. This one's hydroxyl, this is carboxyl, this one hydroxyl. So A, B, C, E, A, B, C, E, H, A, B, C, A, B, C, E, H, A, B, C, E, H. Right, that's done. Okay, next one. Identify all the molecules that are not currently carboxylic acid, although it could form a carboxylic acid when oxidized. So if you are looking for if you are to produce a carboxylic acid during oxidation, you need to look for a primary alcohol. So primary alcohol, C, we are looking for the primary alcohol. Where are those primary alcohol? B has got a primary alcohol, CH2OH. Then C has got a primary alcohol, you see that? CH2OH. Then the E has to go to primary alcohol, you see that? Primary alcohol, then the H. Then the H has got a primary alcohol as well. So the answer is B, C, E, H. All right, the next one, identify all the molecules that contains the ester functional group. My, come on, man, you can understand ester. Easily, ester. Where's my ester? D. F is the answer. We identify all the molecules that would form multiple different products when hydrolyzed. Multiple different products hydrolyzed. You're looking for the ester group. Definitely F is the answer. F, because it when it is hydrolyzed, you are going to form a methanol and that fatty acid, methanol and two different products. Then you can say, so what about H? Look, the problem is H can be hydrolyzed as well. Then you make the same product. This is glucose. So that's why F is the only answer. Identify a molecule that form a ester when heated in the presence of the sulfuric acid. Ah, that could form ester when heated. Heated presence with the sulfuric acid. What is going to be? Oh, look at what is going on here. That is a good one. Good one. Why? Molecule that could form ester. Presence of a concentration. So what I'm saying, they're saying, oh, that's a good one, man. That's a good one. Because, so they are saying, hey, just add sulfuric acid to a molecule, it will form ester. Then you might be thinking, what? Then you have to have a carboxylic acid and an alcohol together to make ester. But we cannot have. They're saying identify a molecule. So the molecule has to have both the carboxylic and hydroxyl functional group for you to do that. So this is the molecule that has got both the carboxylic and the hydroxyl functional group. So when you add sulfuric acid, you heat it up. This this is what will happen. One molecule with the carboxyl group going to react with the same one of those with the hydroxyl group and form ester. So one molecule OH going to go with the others carboxyl group and form ester. So A is the answer. All right, finally we did it. We did it. Whole question. Did it? I might have to. I don't know whether I have recorded the part E or not. Question E. Let's see. I'll talk to you soon. Bye bye.